So question number 6 of October 2022, paper 2-2. Okay, the question is a bit tricky, so we have to be very careful with the statement. It says there is a factorial of an integer, which is the product of all the integers from the number down to 1. Okay, so I'm pretty sure you guys know what a factorial means and what it does. So when we have, let's say, a question and we are trying to figure out the... Okay, so 5 factorial is essentially 5 factorial is basically 5 times 4 times 3 times 2 times 1. This is what's happening. Now the question says, they've already given you the example as well. They're saying that there is recursion that is happening. Okay, recursion is basically a concept of paper 4, but this has been tested in paper 2 as well. It's very simple, and we are supposed to write the function of it. Okay, so a function find base number will be called with the positive non-zero integer value as a parameter, return base number if the parameter is the factorial of the base number, return -1 if the parameter is not a factorial. Okay, so there's no recursion here. I thought there was. Find base number 12 will return -1 because 12 is not a factorial. Okay, like I said, this question is a bit tricky. So what we have to do here essentially is that when we do factorial of 5, when we do 5 factorial like this, so it is 120. Okay, 120 is a factorial value, and this is what we have to check, that if I pass in 120 it should return the factor 5, because 120 is a factorial of 5. If I write 10 factorial, it should return, so if I input, this would be a very large value, so maybe if I have 7 factorial, so if I input 40 into the program, into the module, it should return me 7. And if I input 41, let's say, so that is not a factorial value, so it should return -1. Okay, just give me a... What we're supposed to do is we're supposed to find if 120 is a factorial of any value. The easiest way to do this would be to start multiplying in reverse. Okay, so first time we start with 1 times 1, which is 1. It's not equal to 120. Then we have 1 times 2, which is equal to 2. Then we have 2 times 3, which is equal to 6. Then we have 6 times 4, which is equal to 24. Then we have 24 times 5, which is equal to 120. And yes, here we get a match of 120. Since they're both equal, we'll return the value of this 5, which means that 5 factorial is 120, or basically 120 can be expressed as 5 factorial. Let's say if I input 12 here. Now why is 12 not going to be a correct value? Because if you look at this, 2 times 3 is equal to 6, and then the next value is 4, so 6 times 4 is 24. So in between 12 would have existed, but that is not the case, but we cannot return it. So what we'll keep on doing is we'll keep on multiplying the values, 120 into 6, then some answer here, so that answer will be answer into 7, then whatever that answer is, that answer to multiply by 8, and we'll keep on doing it until the we get to 120. So this is a bit exhaustive method, but yeah, that's the whole point. There's no other way of finding if the value is can be expressed as a base value for a factorial value or not, right? So how do we do this multiplication? Just like we do total is equal to total plus value, instead of that we're simply going to say product is equal to product times value, and then it will do the same effect. So if I have 1 2 3 4, so totaling would have given me 7 8 9 10, but in case of multiplication 1 2 3 4, if I am multiplying the values all together, so I get 12 into 2 is 24, and that is what factorial is. Basically this calculates the factorial of 4, which is 4 into 3 into 2 into 1. Right, now let's try to attempt this in pseudocode. Okay, so how do we write the solution for this? In order to do that, we have to create a function. The name of the function is find base number. So we have function find base number, and this would be some number, and then we'll pass it as an integer, and it will return an integer, and then we'll do end function. We'll leave the space for declaration in the start. They must always be done if you want to get full marks. So declare the values. Okay, so return the base number if the value is true, otherwise -1 if not, false. Okay, so we'll return -1 if the value is not a base case. Okay, otherwise now we have to use a for loop. So like we discussed, how do we find the product? Product is equal to product times value, and this is the value that will keep on changing. This value will be from 1 till our number. Maybe in our case it was 120, 130, etc. Okay, so this is how we're supposed to find the product. Okay, so we'll start our for loop from, let's say, let's call it current, from 1 to, and we'll go all the way till number, and then let's create the product, and product we initially set to empty, and then every time we'll say product is equal to product times the value of the current number, and then we'll do next current. Okay, so if we do it till this point, just what will happen? So output product. So again, let's say the number is 5, or maybe the number is 5, so this becomes 5. So for the first product would be 1 times 5, then 5 gets stored into product. Then next time the value of current becomes 2, so the new product would be 10. Then next time 10 is written in the product, and then we get the next value, which is 3, so it becomes 30. And this should be 1 time, okay, no, my bad, sorry, I am starting from 5. This is all set to 1. So product is set to 1, and so product is initially set to 1, and current is also set to 1, right? So 1 times 1 is 1. So the new value of product is 1. So 1 times next value is 2. So 1 times 2 is 2. So the next product is 2. So then 2 times the next value is 3. 3 times 2 is 6. Then we get 6 here, and then the next value of the previous value of product was 6. So 6 into 4 is now 24. And then lastly, let's just end it here. So we get 24 here, and then 24 times 5 is going to be 120. So since we passed in 5, we know for sure that between 2 and 6 it does not exist, so that would not be the case, but this will keep on running. But in between, if we ever at any point, if we find, so if product at any point becomes equal to the number, then we are simply going to return the value of that number. So let's say we got 24 times 5 became 120, and let's say we had passed in 120, so we return the number, the value of current here, which is our variable name is current. So this will return current, so it will instantly terminate the function and it would return 5, and the rest of the loop will not work. Okay, so going back to the question, so this was the basic working. Okay, now we are going to get rid of this example that we had done. Okay, so right now the code is not really efficient, because let's say if you're searching for maybe 5 or maybe 12, and we know that 12 does not exist here. So bringing back the example, we know that between 6 and 24, 12 cannot exist. So after this 6 and 24, all the other remaining values all the way till 120, let's say, if that is the number, none of the values would be able to store our 12th number. So we can add an additional check here, which would make it more efficient. So let's say we'll check if the product becomes greater than the number value, then we'll return -1 as well. Okay, what does this mean? So let's say the number that we passed in is 12. This is just for example purpose, and then the 12 gets copied into number. Okay, so 2 is not equal to 12. Then we do the next product, 6 is not equal to 12, and then 24 is the product, and 24 is also not equal to 12. But at this point we know for sure that since the product has become larger than the number itself, that the number cannot exist. So within the loop we can just return -1, which means that the value cannot be a base number for any factorial number. So cleaning up the code, we'll get rid of this, and we'll have the number here, and let's remove this as well, and this is it. Okay, so this is a perfectly working solution, which is also efficient for question number 6. Okay, and going to, okay, now looking at the exam report for this quickly, a very small number of good solutions were seen. There were many cases where candidates made little or no attempt at a solution and majority gained little credit. Most candidates required the decision to whether the parameter value had been reached was often in some form. The use of modern diff were regularly seen, but they were used correctly. Okay, so it was not a well done question at all. Okay, now in the second table they are talking about validation checks. So and in fact let's quickly discuss it directly from the working scheme. So we are supposed to complete the table for 4 invalid strings. This is question number 6 part B. Okay, so here we have a string. They're saying is allowed to input a sequence of values to be checked. The user will input one value at a time. The variables used to store the number input has to be of type string because the user will input and to actually end the program. Value input will be converted into an integer and passed to this function. Give 4 invalid strings that may be used to test distinct aspects of required validation. Okay, so basically we are going to pass in some value and then we write end, and then we're just going to get this value part out into an integer form. So directly going to the marking scheme. So if we just write string, there is no end here. If we just write a decimal value, then it's not an integer value. If we write a negative number, then it is a non-positive number, and if we write an empty string, then that has no significance. Okay, and then you can also use the wrong case. So instead of writing end with an uppercase E, you are writing it with lowercase e. So this could be the answer. Okay, moving on. Question 7 is another important pseudocode question. Okay, so what is being asked in this question? So let's read it and highlight the important part out. Okay, a teacher is designing a program to perform simple syntax checks on a program written by the students. Okay, 2 global 1D arrays. So global means unless asked, they would already be initialized for you. They are used to store the syntax error data. Both array contains 500 elements. Array error code contains integer values. Okay, that represents an error between 1 to 800. Error text contains string values that represent an error description. Okay, whenever we get a question like this, we should always be visualizing the solution. Okay, then the next part says the following diagram shows an example of the array. Okay, so they've already done the visualization for us as well. We should do it on our own too. So we have 1, 2, 3, 4, 5, 6, etc. And then we have some error codes here. So there are 2 1D arrays. So the first one would be error code, and then we have error text. So this is error code, and then this is error text. It could have been done using a 2D array as well, but then I think there would be a type conflict issue. Yes, because these are of type integer. What we could have converted them using the string to num function. Okay, so error code 10 means invalid identifier name. So just quickly, invalid name. Then we have 20, which is essentially bracket mismatch. And then I'll just write one more, that is 30, which is no declaration. Here we go. And then I'm just putting dots that there would be some values here. Okay, this goes all the way till 500 indices. Till 500. Okay, here we go. So the question says there may be less than 500 errors. So the corresponding elements in both arrays may be unused. They will have the error code value 999. The value of unseen elements in error text is undefined. Okay, so the unused elements in error code would be set to 999. So this could be 999, this could be 999. And then the error text would be undefined. So that means it could be an empty string. Okay, it doesn't mean that it would literally be undefined. UNDEFIND wouldn't be written. It would just be an empty string. That is what the undefined is meaning in this case. Okay, then in the next part they're saying that Okay, they're saying values in the error code array are sorted in ascending order, but not all values may be present. For example, there may be no error code 31. Okay, in error 31, okay, so the array is already sorted, and as explanatory, there might be some errors that are missed. Okay, output array is a module and unsort array is a module. I think we have tried output, yes. Okay, to write output module, we have to take two parameters as an integer, and we are not returning a value anywhere here, so this must be a procedure. So let's write the header part of it. So this would be a procedure output error. Okay, there would be two parameters here, a line number and an error number. Okay, so let's call it line number and an error number, and both will be type integer, and then we'll have end procedure. By the way, we forgot to declare variables here, so this should be declared product as an integer, and then current will also be an integer, so for loop variable must also be defined, and that's it. Okay, going back, so I'll leave the space for declaration here. Okay, and then they're saying search for the error number in the error code array if found. Okay, so we have the error code array here, we're just looking for a number. Let's say we're looking for number 50, so we have to go all the way till we find the value 50, or we end up finding any value that's greater than them. Outputs the corresponding error description and the line number for bracket. For example, bracket mismatch on line 34. Okay, so let's say if we find an error at line 3, then that means we can find the error text in index 3 of the error text. Similarly, if we find error code 10 at index 1, that means the error text would be in the error array at the same index 1. So same index mapping is being done here. If not found, output the line numbering and a warning, for example this. Okay, so when do we stop searching? The problem clearly states that the array is sorted in ascending order, right? The error code array are stored in ascending order, which means, let's say if I'm looking for error 40, so 40 is greater than 10, but it's not equal to 10, it's greater than 20, it's greater than 30, and maybe let's write 50 here. So we compare 40 greater than 20, and it becomes less than 50. Now since the array is sorted, we are guaranteed that 40 cannot exist in the remaining, let's say 595 indices, so we do not even need to check them, and we can just end. Or the other terminating condition would be when we have seen all the 500 indices of the error code array and we do not find the value, right? So what would be the terminating condition? So if I use repeat until, the terminating condition would be all indices seen, or the line number becomes greater than the current line number. Okay, the line number that we're looking for becomes greater than the current line number. Again, it means if the line number we're looking for is line maybe 40, and we know we have found 50, that means 40 cannot exist here. So line number becomes, yeah, that's the idea. And this line number, so in fact this should be when the current line becomes greater than the line number. Okay, how would we get this current line? This will get from the array of error code. Okay, so let's write this current line. We'll get it from the error code array at some index, and then index would be set to 1 like this. Let's see if it starts from 0 or 1. It starts from 1. Okay, looks good till this point. So what we have done is we have simply set the index to 1. We are getting one value of error code at a time, so it would be 10, 20, 50, and then we have to do it until the current line becomes greater than the line number that we're looking for. So the current line right now is 10, and maybe I'm looking for 40, so then this is again less than 40, it becomes greater than 40, so this condition would be triggered, and then the loop would end. Or all indices seen. All indices seen means that we have seen all the whole size of the array, which is 500. It's given to us, so until index becomes equal to 500, or since we started from 1, it becomes greater than 500. Okay, and every time we read the line and we check, so we'll do index is equal to index plus 1 like this. So we repeat, we start from 1, we get the current value, and then we check, is index greater than 500? No. Or is the current line greater than number? If that is not the case, so we keep on repeating this again and again, again and again. So this is pretty simple. Okay, now in the next part, they're saying this should be set to error number, and then we'll add one more condition to check if we've actually found the value or not. So we'll check, or we can just use a flag because we'll then have to repeat the condition again. So instead we can save our time and write if found then, and we set the found to false initially, just like we do in linear search, and then we check here if the value in the current error code we should also change this to current error to avoid any confusion. This should be current error. Okay, so we check if the current error at any points becomes equal to the error that we're looking for, which would be the error number that we are looking for, the target, like this. So then error code, yes. If that is the case, so we set the found flag to true, and then we do end if. Okay, so this is just simple linear search. We're getting the error code, we're checking if it is equal to the value that we're looking for. If it is, we set the found to true, and then we add another condition here, or found becomes equal to true. And then when the loop ends, the loop would end because of one of these multiple conditions. So we have to make another check here, and then we check if found was set to true at any point, then that means that the value exists, and then we have to output. So what do we have to output? The question says you have to output bracket mismatch on line 34, which means we have to find the error text at the same index. So we'll write error text current index, comma, on line, comma, and then we have to get the line number. So the line number, we'll get it from this parameter that we passed in, whatever it would be. So maybe line 50, and this would be it. And then we'll do else. If found was never set to true, then that means that the error does not exist. So the output will be unknown error on line 34. So I'll just copy this part, and this would be unknown error and online, and the line number that's given to us, and then this would be end if. So this is the whole solution. There could be many other ways of doing it, but this is the one that we discussed and did. Again, we got the current error that was given to us using the parameter. So let's say the error number they've given us is error number maybe 20, or maybe we were talking about 40. So now we have to look for 40. So what we did is we started from the first index. We got 10. We checked is it equal to 40. If that is not the case, we go to the next index. So we went to the second index. Here the array was 20. 20 is still not equal to 40, and we keep on doing this until you've seen the whole array, or the current array becomes greater than the error number we're looking for. Again, example, when we land at 50, we know that 40 cannot exist, or when we have found the value. And when we found the value, we output the line number, and otherwise we just output an error as stated in the question. Okay, so this wasn't really difficult, just a traditional linear search question. Okay, now they're saying in part we write an efficient bubble sort algorithm in pseudocode for the module sort arrays. Okay, now what does sort arrays do? So sort arrays will sort the array into ascending order of error code. Okay, now the keyword here is arrays. Okay, so that means we have to sort both arrays, which means let's say if we have a value 2 here. Now 2 and 10 are out of order, so I'll swap them, 2 and 10, and I'll also need to swap their errors like this. So now this is correct. Otherwise, what will happen is you'll assign the wrong error code to the wrong line number, which will mess up the whole thing. Going back to what we were discussing, so let's say we have 2 rows that are out of order, 2 error codes. So in order to swap them, we have to swap their error codes. So 10 goes here, 2 goes here. Similarly, their error texts have to be swapped as well. accordingly, otherwise it would end up mixing up the data. So now we have tried the efficient bubble sort. Okay, efficient bubble sort will keep on tracking that if at any certain point the whole array has become sorted. If it does become sorted, then we will not continue with the sorting process. So if you look at this quickly, let's assume all the values are 999, so the array is sorted now, and we don't need to run it maybe, let's say, 500 more times, yeah, 498 more times. So in order to make it efficient, what we do, there are two methods. So for efficient, what we do is we use a conditional outer loop to check if no swaps were done at all, and then we in the inner loop we reduce inner loop iterations by 1 every time. Okay, why is that so? So a quick example of the example I often show, this one. So in bubble sort, what happens is that every time the rightmost side gets sorted one by one. Okay, so we have, let's start with the first value. So in the first set of iterations, rightmost value would be 9 and it gets sorted, so we don't need to look at 9. Next time 8 will get sorted, so we don't need to look at 8 and 9. Next time 5 will get sorted. So every time we can reduce the iterations by 1. So initially we started from 7, then we went to 6, then 5, then 4, then 3, then 2, then 1. So there are two ways of making it efficient, and we'll use both of them to actually make our code and our bubble sort as efficient as possible. Okay, so in order to do this now, this is part B of question number 7. Okay, so we are writing a solution to sort arrays. This would be a procedure sort arrays, and we'll have the end procedure. Okay, so declaration are supposed to be done. Again, we need to do them here. So we have the declare index as integer, and then I think you guys can figure out the remaining one. Okay, if you use any for loop, so you have to add that loop variable in here as well. Okay, now to write the solution for this, first of all, declaration, we'll do it them afterwards. Then we'll use a repeat until, and we'll say repeat until swap is equal to false. Okay, so until no swaps were done, and then every time we'll assume that swapping will be done. And then there could be many different variations of this. You can use 1 and 0, you can use string values, you can use sorted here, that you'll assume that the array is sorted initially, and then you can assume that the array is not sorted, etc. So whatever works for you, that is fine. So I'm initially assuming that swapping will be done, and then I'll keep on repeating this loop until swapping has been set to false. And initially I'll assume that swapping is set to true. Okay, so if at any point until swapping is set to, okay, I'll assume no swapping was done here, and then at the end I'll also check if no swapping was done throughout. That means that the array is sorted. Okay, now let's start. For the inner loop, we'll have for j or I or whatever 1 to the number of values in the array, which is equal to, okay, the size of the array is 500, and as always, you guys remember we have to go till 499. And the reason is when we are at in the bubble sort, what we do is we look at the current value and the next value, right? So when will be at 500, so the next value would become 501, which would be out of array indices. So we have to just do it till 499. So at 499 we'll compare it with 500, and that's it. Okay, so we'll do it this way, and like we discussed, we should also reduce the number of iterations in the inner loop. So this would become for I, for j, 1 to 499, and this should be some variable, let's call it size, and then every time we'll subtract 1 from it. Okay, so this is going to be 1 to size, and then every time next j, we do next j, and before we do that, we'll say size is equal to, in fact, outside of this, once we have seen the whole, size is equal to size minus 1. Okay, why am I doing this? this is again the part that I showed you guys in the video. When we have ran the whole loop once, outer loop once, so the rightmost side is guaranteed to be sorted. So when the rightmost side is guaranteed to be sorted, then that means we don't need to look at it. So let's say if the size is set to initially 499, so after this inner loop has run completely, the size would go to 498. So next time it won't look at the last value, basically. Then next time it would become 497, 496. Eventually there might come a point where the majority part of the array is sorted, and then we'll just be looking at the 10 values. So this is one way of making it efficient. We keep on reducing the size of the array, basically the number of values that we have to sort. So I'll bring back the size variable, and then I should set the size variable to 499 initially, right? Okay, so this is just basically the skeleton code right now. Okay, and then let's start the actual swapping part. So I believe everything is in order here. Now let's start. So we'll check if the name of the array is error code and error text. Okay, so we'll be looking at error code values. Okay, so if error code current index j is greater than error code index plus 1. Again, what does it mean? We're at index 1 here, and we compare the value at index 2 here. So if they're out of order, we'll swap them. So let's say this is 10, and then this is maybe 1. So since they're out of order, so now we'll swap them, or maybe let's make it 8. So 8 goes here and 10 goes here. And similarly, we swap their descriptions as well. If we are able to figure it out for one array, we can simply do it for the next array. Okay, how do we do this? So we have to create a temporary variable in order to not override the values and store them. So let's call it, this is the temp, let's call it temp error, and temp error would store the current value, error code index j. So what are we going to do here? So currently what I'm doing is I'm storing, this is temp error here, and this is temp text here maybe. So in temp error right now, this would be 10 and this would be 8. So I'm storing 10 in temp error. Then in the next step, I'm going to copy this 8 onto the current index. So how do I do this? I'll write the value of the next index should be copied onto the current index like this, error code. So copy value from next index onto current index. So if the value of j is, let's say 1, so the value at index 2 gets copied at value at index 1, and this is what's happening here. So this 8 at index 2 gets copied at 8 at index 1, but we had already copied 10 here, so now we need to bring back the value of 10, and that would go on the second index now, which is the next index. So I'll say error code next index, bring back the value from temp error. So temp error had stored 10 here, right? So I'll bring back this 10 and I'll store it in the next index, and then both of these values have been successfully sorted. Okay, if you guys understand it till this point, then the remaining part is super easy. I just need to repeat the whole thing for the text. So I'll say temp text is equal to error, what was the name of the array? Error text. Okay, so error text, current index j, and then error text, this should be j by the way, and this should be j plus 1. Okay, so then error text index j would be error text index j plus 1, and then error text j plus 1 would get the value back from temp text, and that's it. So within these 6 lines, we have swapped the values, and now we initially set the swapping to false, right? We are assuming that swapping wouldn't be done right now. But since we have done swapping, so I'll just set the swapping to true again. So what will happen is there would come a point when the whole array is sorted. So the whole loop would have run for 1 to, let's say, 500 times, and then this condition would have never become true because the array would have been sorted. Let's say in this case, let's say the array is sorted, right? So since the array is sorted till here, so throughout this condition would not work. Since this condition does not work, swapping does not get set to true. And since we had initially set it to false and the for loop ends, and then we check is swapping equal to false yet? Yes. So it was initially set to false. This line never happened. So since it remained false, that means that the array is fully sorted and we do not need to change the values further, sort the values further. And this would be a fully efficient working bubble sort code worth 6, in fact worth 8 marks. So if you look at the exam report for this, question 7 part B, in fact let's look at part A. A common mistake was to omit the end procedure statement, so I'm pretty sure you guys don't do that anymore. And then the incorrect use of assignment operator in a comparison expression, which means students were using equal sign instead of the comparison operator. And then ampersand often did not first convert the line number to a string that chose to output a camera separated list, etc. And then this was std sort with an added requirement of needing to apply the swapping on both arrays. Excellent solutions were seen. There were also many ends where candidates made little or no attempt. So in most cases, the condition loop was a potential solution. Many solutions lacked an inner loop, and yeah, so nothing really new here.
वैसे जो bubble sort है, मैंने ना रट्टा मारा when I just fit it into situations. Is that okay?
It's fine, I think.
Do I need to understand it though?
Yes, you need to. You understood what we've done here, right?
Yeah,
हाँ तो
sort
बस
of.
ठीक है, बस ठीक है. अगर ये आपको आता है तो that's good enough. ये इससे ज़्यादा मुश्किल क्वेश्चन नहीं आ सकता. This is the maximum difficulty that you can get in AS.
And okay.
Alright, so let's start October-November 2022, paper 2-2. This is a moderate paper to some extent with some complicated parts here and there. So we'll open the insert document as well. Alright, so a programmer is going to solve a problem, and the question says why programmer may decide to use a subroutine. So this is very simple theoretical stuff. We use subroutines. So subroutines are basically the procedures and functions. So we can reuse the code and call it as many times as we want without rewriting. Okay, so this is important, and then it simply makes the debugging easier as code is split into modules. So it just becomes easier to debug, to write, to maintain, to test, etc. This is simple theoretical stuff. Okay, a procedure header is shown. Give the correct terms for the identifiers count, message, and explain their use. Okay, can you guys tell me what is the purpose of count and message? So the answer here would be that these are the parameters. And why do we use them? Because we use them to pass in values into the module, and in our case it's a procedure, so we'll call it to pass in values into the procedure. Okay, then so this is a theoretical question. I'm just skipping this. Okay, then the next one, we have to evaluate some expressions here. Part of an identifier table is shown. Complete the table by evaluating each expression using the example values. Okay, so we have the mid function here. So we know that what mid function does, it will extract some part of the string, basically a substring out of it. Okay, so they're saying we have a char list. Char list contains the value A, B, C, D, E, F. So I'll just write it separately, A, B, C, D, E, F. Then month of flag date. Okay, so flag day is the date. The month is going to be in DMY format. So date is always written in this format, DMY. Okay, it's written in the insert document as well. So this would be the month. So we basically are saying A, B, C, D, E, F, comma 4, and then it says comma 1. So mid, comma 4, comma 1, what does it do? Mid, we are saying that start from the character 4 and get me one character. This is what we are suggesting. So starting from the fourth character, we have 1, 2, 3, 4. So E is the fourth character, and then we're saying starting from the fourth character, get me one character. So it would simply be evaluating to E. And then since E is, this should be A, B, C, D. I think I forgot C here. Yes, it should be A, B, C, D. So this should be D then. So if I just write D, this would not get me a mark because quotation marks are missing. Since we extracted a character, this must be in single quotation marks like this. So if I write it properly, it would be like this. Okay, so if you just write D only, this would be wrong. String and characters must always be inside quotation marks. Okay, next part, so inside the in function we are doing some division. We have count is set to 29. Okay, 29, and 29 divided by length of char list. Okay, char list is a string, so we can use the length function, which will count the number of characters. So they are 1 2 3 4 5 6. Okay, 29 divided by 6, so that would be 6 times 4, which is 28. But since we are in the int function, there wouldn't be any decimal places after this. Okay, int will just return you the non-decimal part. So if you look at this in the insert document, again, it's always given to you. So here it will say returns the integer part. So 27.5 will be converted to 27. So it will just return us 29 divided by 6. This should be, in fact, not 28, 4. 6 times 5 would be 30, so 6 times 4.5 I think would be 29, so it should return us just 4 here. And then we have these operators. These are the operators we have, that and, or, not. So they are the relational operators, and they will always return you true or false, right? So this is and. Okay, so in case of and, when either of the input is false, the whole output is false. So count is greater than or equal to 29. So 29 is actually greater than or equal to 29. So this would evaluate to true. And it says flag day is greater than 23. Okay, so flag day is a date, and the day number is 23. So it's checking is 23 greater than 23, which is obviously not the case because they're same. So it would become true and false, which overall will evaluate to false, like this. So this gets us 3 marks. Now the next part, question 2. The algorithm will process data from a test taken by a group of students. The algorithm will prompt and input the name and the test mark for each of 35 students. The algorithm will add the name of all the students with a test mark of less than 20 to an existing file. Okay. When we talk about an existing file, which file modes are we referring to, or which file mode singular are we referring to? So we have read, we have write, and then we have append. So in existing file, we always have to use append mode because it will be adding at the end of the file, and if we open it in the write mode, it will just overwrite all the existing contents of the file. Okay, so they're saying describe the steps, do not include pseudocode. Okay, again, this is going to be a bit tricky. So again, what do we have to do? It will ask the user to input 35 names, and then it will add all the 35 names, but with the ones who scored less than 20 marks to the support list. Okay, so how do we do this? Now this is very simple. You just have to write the steps that we discussed. So first of all, we are going to open support.
Sir. So
we will open the support list.txt file in append mode. This is very important. If you don't write this, you will lose 1 mark. Then they're saying that you have to ask the user to input mark for 35 students. So then we will ask them to input the values. So use a loop and ask the user to, or run a loop for 35 times and ask user to input a name every time. Then you check name, okay, marks, input marks every time. Okay, so once we do that, then in the next part, we are simply going to check if the marks are less than 20, right? That is what the question says. Check, use if condition to check if mark is less than 20. And if that is so, if true, then we will then write the name to the support list file. Otherwise, keep on repeating the process from the start, from step 2 maybe, and we can just label these as steps so it becomes easier to follow. So this could be step 1, then this could be step 2, 3, 4, and 5, like this. So this is how you can generally answer these descriptive questions, by mentioning the steps, and then you can tell that you can redo the step 1 or 2 or whatever. So again, what did we do? We asked the user to input 35 names and marks, and then we are going to check if the mark is less than 20. Then we will add it to the file. Otherwise, we'll go back and we just keep on repeating the loop, and then this process keeps on going. This was simple. Okay, explain why it may be better. Explain why it may be better to store the names in a file rather than in an array. Okay, this is very simple because files are stored permanently. Right? That is why we have files in the first place. So you can just literally write that the names would remain in file permanently, whereas array will lose contents when computer will be shut down or something, because you are storing the data in an array and that array is being stored in RAM, and when you restart a computer, all the contents of the RAM are gone, so the array would be gone. And then they're saying the same thing that we discussed before. Explain why the write mode cannot be used in the answer to part 2a. So as we already discussed, that write mode will overwrite all the existing contents of the file, which would then be lost. So we don't want to lose the contents, we just want to write to the existing contents, so that would not be a good idea. Okay, this is a very simple state transition diagram program. In this, they're saying you have a state transition diagram. So we are given a starting state, this is S1, and from S1 we have to eventually move to these other states. Okay, so they're saying at S1 there is no input, there is no output, the first state is S1. Okay, so when you get input A, what would be the output, what would be the next state? So at state S1, if we get input A, the output is X, and we go to state 2, right? So this is what you have to write here. So at input A, the output would be output X. You'll write the complete form, I'm just writing the short form. This is the output. So, and then the next state we go to is S2, because that is where the arrow is taking us. Okay, now in the next part, when we are at S2, they're saying you would still remain at S2 from S2. So how would that work? So at S2, what would be the input to remain at S2? That would be input A. So we'll write input A here. Again, I'm writing short form, and then there's no value after input A, so there wouldn't be any output. So we can just leave it empty, or we can just call it none. Okay, then we're still at S2. So how do we get output W at S2? Okay, let's see. For output W, we need, this is output W from S2. For this, we need input B. Okay, so I'll give input B. And then if I have input B, then where do I go to? I'm going to state 3 from state 2. So I'll write S3 here. And then again at S3, how do I get output W? Let's see. So there is no output here, so not this one. So this is output W. So that means we'll input A and we'll go to S4. So we'll input A and then we'll go to S4. That's the idea. Okay. Moving on to the next part. So question number 3. This is again a description question related to stacks. Okay, so how do stacks work? Just a quick recap. Stacks. Yeah, so the question says a stack is used in the program. Identify one other example. Okay, so we actually do not have to talk about stack. We need to talk about some other ADTs. So the other ADTs that we have are, we have the queues, we have the linked list, and we have, that's what merit. So these are the only ones we have for now. Other one is we have hash tables, graphs, binary trees, but they're all in A2, so we cannot write them here. So in this case, we can just talk about queues. And then they're saying what are the features of queues. Okay, so how do queue work? So queues work literally how we have queues in real life. It means, so when I'll add a value, I'll add it towards the end of the queue, and when I have to remove a value, it would be done from the start of the queue. So there are 3 values now. So if I want to remove the value, it would be removed from the first, which is the head. So if I dequeue it, so 12 would be gone. If I dequeue again, 35 would be gone. So it is the first in, first out data structure, where the first value that goes in would be the first value that goes out. which is different from how the stack works, because stack works in the opposite way. So the the features would be that there are two pointers, one points, or you can just call them with names. There are 2 pointers. Head pointer points to the start, to the index from where the element will be removed, and then there is a tail pointer which points to the index from where the element will be added, at where the element would be added. Or you can reword it in your own way. So we got 3 marks for this. Okay, an additional thing that you could write, if it was maybe 4 marks, then that it is a FIFO structure, that is the first in first out data structure, like this. Then they're saying that explain, again this is a descriptive question, explain how the stack can be implemented using an array. Okay, so again, how do stacks work? We have an array in the code, and then we add values into the array, which is pointed to by the top pointer. So there would be an index which we put pointing to the value that we last pushed in. So like this, top of stack is pointing to 23. If I pop it, it points to 86 now. If I pop it again, it goes to 4, and the first value that we added was 50, and it is the last value that will go out of the stack. So this is how stacks work. Now how do we implement them using arrays? So in order to do that, we need to create an array. So here we actually have to describe the whole setup. This is a 5-mark question, so 5 points. So first of all, we talk about declaration, then pointers, and then any functions that we want to create. So we'll say that we declare array, and usually it's of type string. Declare array for stack of type string. Then we declare integer variable to store for top of stack, or let's call it top pointer, or let's call it top, or value of top pointer. Okay, so what is top pointer? This is going to store the current value, point to the current index to where the last value is stored. So the top is going to point to 56 here, right? Or it will point to the index, so it would be at index 2 right now. This would be index 1, this would be index 2. Okay, so then we have these two things. Then what will it do? So top pointer will store the index, the index of the current value at the top of stack. So again, what does this mean? So it means that top will be pointing to the current value, which is 56, or index 2, depending on the implementation. So you've gotten 3 marks for this. Then we can talk about, there would be a push function. Push function would first check if stack is full. If not, then add value at the top of stack and increment the pointer. And then there would be a pop function which would first check if stack is empty. If not, then remove value pointed to by the top of stack pointer, something like this. So again, what does this mean? So when I have to push a value, that means I'm adding value on the top of the stack, like this. And when I press the pop button, it means the value would be gone. It would be removed from the stack, like this. And if I pop it again, it's gone. This is what we have to write in the question. So this is a very descriptive question, and if you miss any points, you will lose marks. Okay, so we get 5, hopefully more than 5. Okay, now let's do this. This is an interesting one. We have some state of the stack right now. They're saying that a second stack is used in a program. The diagram below shows the initial state of this stack. Okay, so this is the initial state, X, Y, Z, P. And then what we have to do is that we have to stack value X is at the top of the stack and was the last item added. So X is the last item added and the stack pointer is pointing to it. So whatever the last value will add will point the stack pointer to there. Okay. Uppercase letters are used to represent different data values. Stack operations have been performed. Complete the diagram and store the stage after each group of the operations. Include the SP after each group. Okay. First of all, they're saying push D and push E. Okay, so this is very simple. First we'll make the stack pointer point to 954 like this, and then we'll put the value of D here. Then when the value of D is here, so we'll increment the stack pointer by 1, and then we'll make it point to here, and then we'll store the value of E. And this is where the stack pointer will be pointing, and then everything else remains the same. So X, Y, Z, and P, they all remain the same. And you must make sure that the stack pointer is pointing properly to the current value that we stored at the top of the stack. So group 1 is done. Then they're saying group 2 is 3 popping functions. Okay, when we have to pop the function, you might notice that it literally removes the value from the stack, but in our syllabus we are not going to delete the value, we'll just keep the value there. Instead we'll just update the stack pointer. So that means we are not going to remove any of these values. So they have said pop it 3 times. So popping means that technically E would be gone, and then stack pointer will point to D, and then D will be gone, and then stack pointer will point to X, and then X would be gone and stack pointer will point to Y, like this, right? So if we just do it neatly without crossing out any values, it simply means everything will be written as it is. So this would be E, this would be D, X, Y, Z, P, but since we have popped 3 times, so 1, 2, 3, so SP would be pointing here on Y. And then they're saying in the, so we're done with this, and then they're saying in the group 3 we have to push value A, B. Okay, so stack pointer is here right now, so we have P, Z, and Y. So they are saying that now you have to push value of A, which means that we are going to add A on wherever the stack pointer was pointing to. So first of all, stack pointer will get incremented by 1, and then in place of X will store A, right? Then there it says push B, so again stack pointer will get incremented by 1, and the next value is D, so B will replace D. And then they're saying pop, so right now the stack pointer is pointing to B here, like this. So now they're saying pop this value, so pop means we bring down the value of stack pointer, and stack pointer will point to A here, this is where it will be pointing. And then it says push C, so this would be a new value that we have to push. So again, to push the value, we'll first increment the stack pointer by 1, and then we'll override this value with C. So to do it, to write it again, this is where C would be stored, and this is where the stack pointer would be pointing to, and then this value would be gone. So it would become P, Z, Y, A, C, and oh, there's E as well. My bad, I forgot to draw. This E remains as it is, so this E is here as well. Alright, so moving on to the next question, we have this flowchart. They're saying write the equivalent pseudocode of this algorithm. Okay, this would be an interesting one. So I'll spread the screen and then we'll do it. Okay, so let's do this question. So question number 4. We have a flowchart that we have to convert it into pseudocode. First of all, we're taking an input. Then this is the box that we use for any subroutine call. Then we are setting the total to 0 here, and then we're setting index to 4 here. So this whole part here till this point is not part of a loop, right? This is not part of the loop. This is the part below is all going into a loop. So let's do the first 4 lines quickly. Very simple. We'll say input user ID. Then it says set average to get average user ID. So get average would be a function as it is returning a value user ID, and then this would go to average like this with an arrow, and arrow must always be from right to left, not otherwise. Then it says set total to 0 and index to 4, so total is set to 0. Okay, we are not going to set index directly to 4 here because we'll see if index is being used in the loop or not. Okay, so what is going inside the loop now? First of all, we set the index to 4 and we check is index less than 7. That means we know the number of iterations, which means whenever the iterations are known, so for known iterations we use a for loop, and we know that we are starting from 4 and then it is going to end if the value becomes more than 7, right? And this is where we're going to end the loop. So that means we can use a for loop which will be for the value of index is index for index 4 to 7 like this, and this would be next index. And then after this, once the loop ends, we are going to run this line, update line, which is update user ID, and this would be user ID comma total. So this would be update user ID comma total. And since the no value is being assigned to the left side of it, this is a procedure. When you get a variable assigning a value, that means it's a function, and otherwise this is going to be a procedure. So for procedure, we have to use the call keyword like this. If this had been a procedure as well, so we would have written call, but since it's a function, we are storing it in a variable, the return value. Okay, everything is clear till this point, hopefully. So nothing else to do. Now inside the loop, we have to do the remaining part. Okay, so inside the loop, they're saying that we have to set the last two same month index. So same logic, we have to last same month index. Then we are checking if average is greater than last. Okay, if no or yes, simple if condition. So it would be if average is greater than last, then we will write add last to total. So total is equal to total is equal to total plus last like this. Else, if that is not the case, so we will do, and they're saying add average to the total here, add average to the total, which means total is equal to total plus average. I think I swapped the errors. Is average greater than last? If yes, then add last to total. Okay, and if it is not, if average is not less than, then add average to total. Okay, this is fine now. Then we end it using an end if, and that's it. This is the whole question. So we just, this was the only
last.
So this should be average is greater than last, and average, add average to total. So this should be total is equal to total plus average, and this should be last. Okay. Okay, so it says, then, so we've written the pseudocode here. Then in the next part, the question says, what is the name of the iterative construct in the flowchart? Okay, so the one that we used here, what is the name of the iterative construct, the one that they have used? So this is simply a count controlled loop, or you can say a precondition loop. They know that they're talking about a loop because when the question says iteration, it obviously means a loop, but they're saying which type of loop. So since it's not mentioned here, so you can just write a count control loop, which is simply the for loop. But writing for loop will not get you the complete mark. It must always be written as a count control loop. Similarly, while loop will not get you the mark. It must be preconditional loop. And then for repeat until, it must always be post-conditional loop like this. Okay, so the correct answer would be that it could be a count control loop because the number of iterations are known, but this could also be done using a conditional loop. So you could have written preconditional loop as well. So both answers are correct. Okay, then we are going to question number 5. So they're asking that you have to examine the pseudocode, and then they're saying that a programmer wants to rewrite the pseudocode as 4 separate if then else if conditions, each containing a single call statement. Okay, so all of them have call statements. They are making a procedure call. This involves writing a single simplified logic expression as the condition in each statement. Write the amended pseudocode. Okay, this is again very simple. So what are we doing here? First we're checking if A is equal to true, then we're checking B is equal to true, then we're checking if C is equal to true, and then we're calling sub1. And we can just literally write this as if A is equal to true, or we don't even need to write if A is equal to true. We can just write A. Because in Boolean values, if we just write the variable name, that means we're referring to if it is true. And B and C. Then call sub1. This is how we can just limit it in one line. And then obviously there would be an end if. Right? Then they're saying that we have to simplify all the other conditions as well. Okay, so when will we call sub2? So sub2 will be called when A is true and B is true and C is not true. Only then we'll go to else. So we'll write something like this. If A and B and this would be not C, then we'll call sub2 like this. Okay, then they're saying else. Okay, when would this else be triggered? When this A is not true, right? So this else would be triggered if the value of A is false, if not A. Then we're checking if B is true and B is true, and then we're checking if C is true and C is true. If that is the case, then we'll call sub 4. So you just have to look at the indentation. Okay, then when do we call this sub 3? Sub 3 will be called when B is not true. Sorry, when C is not true, because this is the same indentation level. So we will write when the value of A is false and the value of B is true and the value of C is false, etc. So now let's write them properly. So the first one was if A and B and C, then I'll just write it in the collab file. So question 5, so this was A, if A and B and C, then we are going to call sub 1 like this, and then we'll do end if. Then in the second part we saw that if the value of A is not true, then we check if value of B is true. So we check if value of A is not true. Well, this was for sub 1, so let me remove the lines. Okay, this was for sub 1, so we're now at sub B. For sub B, we'll check if C is equal to false, B is true and A is true, right? So we'll check if A is true and B is true and not C. C is false, then we'll call sub 2 and then we end if. Okay, then we will talk about sub 3. So when will we call sub 3 or sub 4? Sub 4 is being called when C is equal to true and B is equal to true, but A is not equal to true, right? So the only reason we'll go to this else is when A is false. So A is false, B is true, C is true. So if A is false and B is true and C is true, only then. So we have to merge these. That is what you're referring to. So yes, if B is equal to true, so A would be false in this case, and B is equal to true and C is true, so we have sub 4. Okay, so let's write this. So A, so not A and B and C, this will get us sub 4. Okay, now let's look at the other condition where we'll get sub 4. So we'll also get sub 4 when C is false. Okay, so sub 4 will also be there when C is false, or when we have, so this if condition were true when B is also false. So when C is false and B is false, so when not B and not C, this would be sub 4 basically. Okay, now let's look at sub 3 just to confirm, and then we'll combine them. So sub 3, okay, when would sub 3 work? Sub 3 would work when A is false, B is true, and then C is false. So not A and B and not C. Again, why is that so? Because we came to this point when A is false, then B is true, and then when C is false, so we go to sub 3. And similarly, let me change this. Okay, and then when do we get sub 3 again? Sub 3 will be called when C is false and when B is also false and when A is also false. So basically that's the point. So sub 3 will also be called when not A and B is also false, not B, and C is also false, something of that sort. So we have sub 3 here, C is false, okay, and then we have B is not true, so we go to C here directly, and then when A is not true. Okay, now they're saying we have to combine these. Okay, that is how we have to simplify them. So there would be 4 clauses, and they're saying you have to write simplified conditions. Okay, so the first 2 were very simple that we have written, B sub 1 and sub 2. For sub 3, we can see that in sub 3 we have not A and B and not C, right? And similarly we have not A and not B and not C. So both of these conditions are basically, they need to be true, but we have to simplify them. So what will happen is that B in this case can be just ignored because it says and B and not B. In both cases it's not going to, it's basically going to kind of cancel each other out. So when value of b is, let's say, 1 and the value of b is 0, in both cases the condition would be true. So we can just skip this part of b altogether because it's redundant, because it's just the opposite of each other. So the value of sub3 call would become not a and simply not c. Why? Because again that part is not doing anything. So now going to the last part. Okay, for sub 4, again let's look at sub 4. Sub 4 has not a and b. So b and not b are again, they're going to get eliminated, and then we're left with not a, and then we are left with not c. Okay, so I think we made a mistake here. C, okay, c should be true. So for sub 4 to be true, c should be true. The reason is because we are setting c to false here. So this is not c, this is wrong. So it should be not a and c. Again, this call will happen when c is actually equal to true. So I mistakenly wrote not there. So overall the call becomes not a and c. Then we will call sub 4 and then we end if. This is how it's supposed to be. In fact, let's open the exam report for this.